Okay, MAP4C day 35. Today's lesson is on misusing statistics, and we start off with a couple of cartoons. Isn't that fantastic? The idea in the first one here is the guy's going, whatever this is, bird, doing a door-to-door survey and is biasing the results himself. Whenever it's the respondent's or the surveyor's fault, the person who's conducting the survey, when it's their fault, that's called measurement bias. Measurement bias is when the surveyor is recording things wrong. Somehow. It could be a calculation error, and this one was just him recording the wrong answer. The second one is a person trying to do a survey of average Americans, and these average Americans are not interested. And of course, the old man that's twitching and one eye is bigger than the other, wearing a floaty, is going to do the survey. This is what's called sampling bias, right? You want to survey average Americans, and this is your average American right there. Although I suppose that might be arguable at the time. Sample doesn't match target, right? That's sampling bias. Another one you could say as well, this is like a voluntary response type sample, and these people don't want to do it, so this is actually called a non-response bias as well. You could call it a non-response bias. And this is a bias because a whole bunch of people don't want to participate. People don't participate who should be. And this is kind of just a fun couple of things. And in fact, surrounding statistics, because they're so into every aspect of our lives, there's lots of, fun comics and statements and stuff. I want to show you this one site that's got some neat quotes on it. I'll just let you read them and snicker to yourself quietly. This is a great one. Right there, I'll let you read that one. Oops. What's going on over there? Get some more. Just a few more. Read them. Okay. Just some neat thoughts about stats. Okay, back to the boring lesson now. Actually, this isn't a boring lesson. This is a bit of a fun lesson as well. We're talking about misusing statistics, and we saw two examples in the cartoons, and a lot of those jokes talk about misusing statistics as well. Assess the validity of conclusions presented from surveys in the media. So this idea, a valid conclusion, is one of those that is supported by unbiased data that has been interpreted appropriately. So that would be a valid conclusion. Now what you should do is, there's a case study on page 224. So you go and read the case study on page 224. That's what it looks like right there. And then the questions to consider, and you'll do this just with a partner, you can write down a few ideas if you like, is on page 223. So pause the video and do this now. Okay, hopefully you had a good discussion with a partner or with yourself or whatever. A few things I want to mention about this study that I hope you thought of. First of all, that makes this an invalid conclusion. Hopefully you concluded that this is an invalid conclusion. For one thing, there was only 5 pieces of data, which is too small. Out of all the years and all the countries and all the whatever, 5 years is too small. Okay. The next thing they did, and that there were only 5 led to a high correlation. Another thing they did here to make it look like it was such a strong correlation is they goofed up the graph. Okay, and these graphs, they're not starting at 0, so there's a problem with the scale there. And in fact, this is one of the things we'll talk about today, is this idea of misleading graphs. The big thing here is the whole argument's a bit silly, because if this is the number of women, and the number of women in the workforce is going up, and the number of single parent families is going up, maybe just the population is going up, right? If the population is going up, then wouldn't it make sense that more women are in the workforce and we have more single parent families, just because we have more of every type of family? So it's kind of like there's a common cause to both of these things going up. What the researchers should have done is talked about rates, so population rates. So if I take the number of women in the workforce and divide by the population of Canada at each of those days, and the number of single parent families divided by the number of families in Canada during those years, perhaps that would be a better argument. But otherwise, it's just a really silly argument. Invalid. Don't write in your textbook. Don't write in your textbook. Okay, so hopefully you came across those ideas, or picked out a couple of those ideas. The next part we're going to concentrate on is this idea of a bad graph. So I said this is a bad graph because it exaggerated the correlation a little bit, because it didn't start at 0, right? And that's misleading. And that's a couple of ways we have misleading graphs. And I got a couple of websites, and I'm just going to talk about them, and then we'll take some notes later, okay? Where's my sites here? This one is from Forbes magazine, which is an important business magazine in the United States of America. And there's my favorite one, you see. And they're talking about how that first medal is worth 1,000, but down here, then Germany should be get 2,000 medals. It's all goofed up. That one. And here's a similar one. So maybe it's kind of hard to see, but let me explain it to you. The top 20 tourist generating countries to United States of America. So these are each of the countries, all these countries that send people travel from their country to the United States. And we see the first one is Canada, then Mexico, and then United Kingdom. United Kingdom, that section looks bigger than Mexico and looks bigger than Canada, but it's about the same as the Netherlands and so on. But if you look at the numbers, the number of Canadians that go to America is 14 million. The number that come from the Netherlands to go to United States of America is 400,000. 14 million is that chunk. 400,000 is this chunk. It's way off. They should have just left this graph off. It's totally misleading. And we'll see a couple more like that as well. I don't know if there's any more on this in this woman's article or not. She just talks about why, it's almost entertainment more than it is statistics, those last ones, isn't it? It's just not very good. So how many of you did notice the deception before it was pointed out to you? We now show a bar graph plotted with the data from the labels of Figure 3. Figure 3 was this one. Sorry, I skipped it. Right? Where it looks like the sales are going up quite quickly. But if you use these numbers and actually draw a bar graph, like you've been doing, it's not going up that quickly. It's going up like a straight line. And so using those ones, and we saw that one on that poll the other day, where these numbers on the end, well, we should have figured something was up. That's 75, and this is 335. That doesn't look the right number of times as long. It just doesn't make sense. The values of the labels are not proportional to the lengths of their bars. There's no scale here, and it's even more misleading when they put the lines on there to show that there should be scale. I got one more site for you, and this has got some great ones in it. The old Wikipedia, the pie charts. Good pie chart, bad pie chart. Why is this bad? Well, it looks really cool because it looks in 3D. Well, if you look at it, the pieces that are close look to be bigger than like this piece here is only 5%, but it looks as big as that one on the back, which is 11. So the ones that are at the front, that makes it look like it's 3D, looks bigger than the ones that are at the back. This is better. This is misleading. Here's another example of, like, this is like a pictograph. So this is a, maybe sales, business sales, company A and company B, and we can see company B's sales are 3 times as much as company A. How they should have displayed it is this way, because this one, the height is 3 times as big and the width is the same, so the area is 3 times as much, just like the sales. But if I were to use these little figures here, it actually appears like that company B has got 9 times as much, because when we look with our eyes, we see area. And this one is actually 9 times the area of this one, as shown in this little diagram there. And so, again, this is a misleading graph. And they've got, different, doesn't have to be, little men with ties like this. Any shape works. There's a classic example there. Okay. In pictographs, notice that each of these pieces of fruit, 4 pieces of fruit, but it looks like a lot more bananas were collected, just because the picture is bigger. This is a better pictograph than this one. A truncated graph, they call it. This is what I just call scale problems. A truncated graph was the problem that we saw there. You see how this one starts at 9100, and it looks like, sales are going through the roof. But if you started at 0, it's pretty much been the same every single year, or every single company, or whatever. Now, it's not bad to, sometimes we don't start at 0. Sometimes we want to exaggerate the difference, but it's important, like they say here, it's important to show a break in the graph, so that allows the user to understand that we're demonstrating the differences between the items. Okay? These ones are interesting. Basically, if you change the axis, it can make a graph look like it's growing faster or slower. Okay? So this one down here, there's the normal graph. This is a good graph. But if we squished the years in, it would make the slope look higher. Or if we spread the years out and squish the y-axis in, it made it look like it's growing not as fast. Similarly here, if we change the starting value or the ending values of the y-axis, it can make it look like it's growing faster or slower. Okay, all misleading. I'm not sure. I think that says just about all the ones that I want to say. I think, maybe there's one more. This is one of the ideas of with some missing points. If there's missing points, it can exaggerate the correlation. Having trouble with my scrolling here. More 3D problems. You see on this 3D graph that if we wanted to read a scale from a 3D graph, which one do we measure from? Do we measure, this is we read from the front tip or we read from the back tip? And we see the problems here that, these two are the same height by perspective, but that one looks a lot smaller. It's misleading. 3D graphs are bad. They're just bad. And they have some more information there. So let's just sum up our discussion here. I've been talking for too long anyway, so let's go back to the note and finish up. "3D graphs are bad. They're just bad. And if you wanted to put something in there to help you remember, you could draw a little box like this to make, and then remember like there, or the pie chart where the front one looks huge and the back one that's the same shape looks smaller, right? These two are the same. Improper scaling of pictographs or bar graphs. Well, this is the one with the little guy in the tie, right? Where we could actually fit a whole bunch of these ones in there if I wanted to, right? So if I just wanted to, it's actually 9 times the area, even though I wanted to show 3 times the height. You draw a little diagram to remind that. Scale problems was the idea of we want to show a break in the graph, right? We want to show a break in the graph. If this value here or this value here doesn't start at 0, then it can be misleading. We use a break. Exaggerating correlation or overstating cause effect was one of the problems in the one that we just did, or the case study we just did, was when there was only 5 pieces of data, right? And 5 pieces of data is always going to give you a pretty good linear correlation, but if we were to do more of a sample, maybe the rest would be spread out all over the place and it wouldn't be such a nice line of best fit. That's exaggerating the correlation. Overstating cause effect would be, in the case study, they said that women in the workforce was causing the number of single parent families to go up, was causing divorce. And, maybe it's the other way. Maybe because a woman is in a single parent family, she needs to work to support her family, and it's the other way around. They tried to state that this was causing this when it might be the other way around. And again, it's not, because in this case both of them are caused by population. That's what we mean by overstating cause effect. And homework actually is pretty quick, but it's a good discussion. Read these examples and have a good discussion today.